Hey guys, this video is for questions 9 through 12 of the fall semester review. So we have some graphing inequality questions that we're going to be looking at. First, we're going to look at number 9. So we start by plotting the y-intercept, and this is the same, we do this the same way that we did whenever we had y equals mx plus b. Even though you have the greater than or equal to sign, you still graph it, or you start graphing it the same way. So our y-intercept is this positive 4 right here. So I'm going to put b equals 4, okay? And I can go to the graph. I start at the origin, and then I go up 4. So 1, 2, 3, 4, right here. Right? Then we have to look at our slope, okay? Our slope is this negative 1. Remember, when there's no number there, it implies there is a 1. And in this case, it's going to be negative. So you have negative 1. And when we go to actually graph or plot the points to create the line, we have to do rise over run. So in order to figure out what our rise over run is, we just throw a 1 in the denominator. So our rise is a negative 1, and our run is a 1 also. So go to the y-intercept, you go negative 1 for the rise, over 1 for the run. And then you just keep doing that until you have a couple of points. You don't need to plot every single point, just 2 or 3 is good. Or you can do a few more if you prefer. Make sure that when you graph it, you take the straight edge, or use a straight edge, excuse me. Okay? Also, we need to be careful when we're graphing, because when we graph, we're either going to use a solid or a dashed line. In this case, we have a solid line because the equal sign is underneath the greater than. So it should look something like this. And of course, the arrow's on the end. All right. But now, because we have a greater than or equal to, we not only have the solid line, we also have to shade above. Greater than means above. So your graph should look something similar to this. Okay? So for number 10. All right. In order for us to graph this, we have to solve for y first. Okay? It's not that bad. We have been doing this for most of the year. So in order to solve for y, we need to get rid of this 8x. And we do that on both sides. Okay? So if drawing this line helps you to stay organized, I suggest that you do that. So on the left side, the 8x cancels. You're left with negative 3y is less than or equal to. And right here, you cannot combine these because they are not like terms. The 12 doesn't have a variable, so you cannot subtract the 8 from the 12. They have to stay separate. So you have negative 8x minus 12. All right, so now we need to divide by everything by negative 3. But when you divide by a negative, you have to be careful because you need to flip the sign. So instead of less than or equal to, now it's greater than or equal to. So we have y is greater than or equal to. Negative over negative is a positive, so we have positive 8/3 x. And again, negative over negative is a positive, so we have plus 4. All right, so now we have a slope of 8/3. And we have a y-intercept of positive 4. So go plot the y-intercept at positive 4. And now we've kind of run into a little bit of a problem, because if we did the rise over the run, it's 8/3, we'd be somewhere way up here. Okay, so instead of going up and over and off the graph, we're going to do the opposite. So instead of going up and right, we're going to go down and left. You just have to make sure that since the slope is positive, that your slope stays positive. So we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, and then over 3. Just to verify that we have a slope of 8/3, we can start at this point instead and count up 8. 1, 2, 3, 4, 5, 6, 7, 8. That's my rise of 8, and then my run of 3. All right. Now again, be careful. We have a greater than or equal to, which means we need a solid line on this one. Okay. And since it's greater than or equal to, we can solid line and also shading above the line. So your graph should look like this. All right, so now we're going to turn the page and do number 11. So if you would like to do this by hand, that is totally fine. In order to do that, you need to solve for y first, but we're going to take the shortcut on this one, and we are going to graph it. So you'd start by doing a new document. We don't want to save. And then add a graph. Now remember, you have to hit delete. You cannot just type it in as a function. You have to hit delete, and then you can type it in as a relation. Okay. Did not work, so let me try that again. Okay, so now it should work. All right, so we have a relation, and so we type in exactly what we see. We have 2x plus 3y is less than or equal to 12. So don't forget, in order to find those symbols, you hit tab, you hit control and then equals. So your symbols pop up. It's less than or equal to. And mine is wanting to be, there we go. So try that again. So control equals, the symbol less than or equal to, there we go. And then 12. Calculator's being picky today. So you can see what it looks like, okay? We're not trying to graph it. We are simply trying to list points that are either in the solution or are not in the solutions. So I'm going to list 3, but just know that there are an infinite number of correct answers. So if I'm going to list 3 points that are solutions, I just pick any 3 points that are in this shaded area, or because it's a solid line, it could also be on the line itself. So I'm going to look at my calculator, and it looks to me like the point 0.04 is exactly on the line. So I'm going to put 0.4. I can also see that the origin, 0,0, is an answer. And then just to pick one more, how about -2, +2? So -2, 2. Your answers may be different than mine, and that is totally fine. Like I said, there's an infinite number of solutions. Now, to list 3 points that are not solutions, we have to list the points that are not in the shaded area. So if I'm looking at my calculator, it looks like 0.50 is outside of the shaded area. And then it looks like I could pick 10 and then 5. That one would be somewhere over here. So that means that would be out of the shaded area. And then I can also pick 9, 0. That would be on the x-axis, but it'd be somewhere right about here, I think. Okay. So number 12 is very similar to number 11. We just, start a new document. Okay, don't save. Add graph. And then delete. Type it in as a relation. Okay, so now we have y is greater than 3x plus 1. So y, and then to get the symbols, it's control equals. This time it's greater than, which is already highlighted. And then 3x plus 1. Okay, so if you look here, you see, if you look real close at your calculator, you would see that it is a dotted line. It's probably hard to tell in the video, but it is a dotted line. So in order for us to pick some points that are in the solution set, we cannot choose a point on the line. It just has to be in a shaded area. So it looks like, I'm just going to come up with some, -10, 0, and then -6, 5, and then it looks like 0.3 would be another one. Okay, then just pick a couple of points that are over here, right? You could, or for the ones that are not solutions, you could just pick a couple of points that are over here. Because it does not say equal underneath the symbol, you could pick a point on the line. Let's see, I'm going to pick points 0, -2. I'm going to pick 3, 0, and 5, 3. But you could have had multiple other answers that would have also been correct. So I hope that helped. Keep working on your review. You guys are doing a great job.